Utility Systems, and also joined by our partner Exinda today. My name is David Silsby. I'll be chairing the presentation. I'm joined today also by David Richards, who is Regional Sales Manager for Exinda, and also Justin Headley, who is one of the Exinda technical specialists. We hope not to take too much of your time this morning. We've scheduled for roughly 30 minutes of your time today, and that of course all depends on how many questions we get at the end. So basically the agenda for today is, as you can see on the screen, it's very simple. We'll have Dave Richards, who will briefly describe some of the challenges that are facing organisations today around network and application performance. We're seeing, of course, a lot with the steady migration to the cloud and users taking up more and more web applications, and combined with the increasing demand for streaming media, social networking, etc. This is starting to have an impact on some of the critical business applications that people want to use. And so we're going to be addressing some specific challenges today. And then we'll be handing some time over to Justin, who's going to actually take us through the Exinda solution and specifically show you how the Exinda technology addresses these challenges. I'm pretty sure these are challenges that some of you will have faced from time to time, and there may be other challenges that you're having that we don't specifically address today. But we will, at the conclusion of the presentation, allow some time for some question and answers. And if I could just ask you to submit questions through the question box, which is in the control panel for the GoToWebinar meeting. It's down at the bottom right-hand side. Well, that's where it should be anyway. So with that, I'm going to shut up, and I'll hand over to David Richards now to take you through the first few minutes of the presentation. So over to you, David.
Thanks very much, David. Okay, good morning, everybody. As described, my name is David Richards. I'm a Regional Sales Manager for Exinda. We will keep this very concise. We'll keep it high level as well. You'll be pleased to know that I'm just talking to this one specific slide before I hand over to Justin, who'll go into detail with regard to the interface and the flexibility within the Exinda solution. But I just want to talk to these three separate columns, really. I suppose historically, a business app was a business app, and the internet was the internet. However, what's happened over the last few years is that a significant percentage of business applications are now being delivered over the internet. And we're getting into this sort of blurring area, a grey area really, as to what is a business app and what is a recreational application. Specifically things like Twitter and Facebook. You know, are they nuisance apps or are they business apps? And in reality, the answer to a lot of organizations is they're both. So the challenge today is really understanding what specifically is running on a corporate or an organization's network. And we still have this potential issue where you'll hear cliches such as my application's running slow or the network's running slow, and then the subsequent follow-up to that is the network people blaming the server people and the server people blaming the network people. So in the absence of having very detailed visibility of what's running on the network, it's difficult to be able to apply policies and controls and, if you like, optimize the efficiency of application performance as well as the network. The second point, obviously you have control of your own in-house applications, but as we've just described, many applications are now being delivered as software as a service, or they're coming from cloud-based services where they're not on your site, they're remote. And the fact that they are remote can often add latency and delays or performance impacting aspects. So our point is, once you've got very detailed and granular visibility of what's running on the network, you can then start to make objective decisions about what you actually want to apply controls to. And it's not just about a big switch, you allow one application to everyone or you disallow it to everyone. That's not a granular enough approach these days. And the third point, really, this pertains more to what we would call WAN optimization. But I have to say, WAN optimization is a phrase I'm trying to avoid because it's become a nebulous phrase. It means different things from different vendors. Generally, it means accelerating data. But the reality is that you may not necessarily need to accelerate data. And without the visibility and control elements, you may actually be accelerating bad traffic or non-business critical traffic ahead of business critical traffic. So the point that we want to deliver today is that Exindra offers this holistic three-point approach, which is borne out by major competitors of ours who have gone out and acquired alternative technologies. But we uniquely deliver this in a single appliance, be it a physical appliance or a virtualized appliance, to give you that total visibility and control of not only what's going on the network, but actually optimizing the performance of applications, optimizing the performance of the network, but also enhancing user experience as well. So those are the 3 points that I wanted to bring out. I think logically, if I can now pass to Justin, and he can actually go through the interface.
Thank you, David. If you want to pass me control. Thank you very much. And I will, hopefully you should now all be showing seeing my screen. Not yet. There we go. So my name's Justin. I'm an Exindra technical specialist here. And what I'm going to show you today is the actual Exindra interface and how it can help with all those points that David has just said. So logging into the interface, we're brought into this dashboard view, which gives you a very high-level overview of what is being seen on your network. So we can quite quickly see in the date range of today, yesterday, last 7 days, what applications are running on the network, how utilized the link is, how much of the bandwidth is being used. You can put in, see what recreational applications are there. So this will show you, is the bandwidth that's being used, is that actually business related? And if any applications are being prioritized, what ratio that is. So that's just a very high level dashboard view. What we want to have a look at is, at the current point before putting Exindra in, we don't have visibility. We don't know what is running over our internet connection, what's running on our network. So what we want to do is we want to have visibility of that. So we're having a look at the monitoring section. So the monitoring section has 2 parts to it. First of all, you have a real-time section. So if somebody rings up, my network is being slow, the internet's being slow, emails are coming down slow, file transfers aren't happening, you can go in and you can see what's happening right at this moment. And you'll see in there that the screen just refreshed. And so we're seeing a snapshot of what's going on every 30 seconds. So the first view that we see is the conversations. So we can see what traffic is flowing between 2 devices, what application they're using and what transfer rate they are using, how much bandwidth they are using. You'll see it's broken down into your inbound conversations and outbound, so you can see which direction the traffic's flowing. And you can then also see if anything special is happening with that traffic. So first of all, we see this blue line at the top. That means, and I'll come on to this in a little bit, that means that this traffic is being cached. There's one technology Exindra uses, which is called its edge caching, which is used for web traffic, as it says, a cache. The items in yellow means that they are being then optimized. So FTP is being optimized, and we also see, oh, it's just refreshed, but there's also some HTTP traffic being optimized there. So that's a view of between 2 stations, a conversation. We can also have a look in real time what applications are being used. So we can see HTTP and SMTP is primarily being used inbound. We can also have a look at the individual hosts to see what traffic they are using in real time. And we can see that this IP address is obviously using a high proportion of the bandwidth compared to everything else. Not only can we see the applications, but we can then also see how good those applications are performing at this point. So if someone says, you know, my HTTP, my web isn't working, we can then go into here and we can see what the network response is, what the server delay is, you know, any transaction delays. So it helps you then break down and try and point the finger towards it's the network or it's the servers that are going wrong. And we can also see if any of the hosts are performing badly, how much traffic they are retransmitting, how many has been aborted. You know, these could help lead you to point into a direction to diagnose any faults that are happening on your network at this point. So that's the real-time section of the monitoring. We then have the historical data, and typically an Exzinder box can store statistical data for about 2 years. So the section most people will probably be interested in is the actual applications that are being used. So we can select a whole variety of ranges that we draw the data from. So there's quite a few predefined ranges, or you can actually have a custom range as well. So if you want to, you know, specifically narrow down to a specific day, you can do. So first of all, we're going to look at the groups of data. So Exzinder have come up with some groups of applications that they've put together. For example, web traffic. So that just groups all the web traffic together. And we can see that a high proportion of the data that we are seeing at the moment for the current day is web traffic. What we can do is we can then drill down into that web traffic and actually see what applications are included in that group. So we're then drilling down into the individual applications, and we can see that inbound, majority of it's HTTP, and with a little bit of HTTPS, and some coming in a little bit more HTTPS going outbound. So you have a graph to represent the data, and you also then have the table to show the actual statistics. Again, from here we can say, right, HTTP is taking up a lot of the bandwidth. Let's drill down even further. Let's have a look at the HTTP traffic, and let's see what hosts are using all of that traffic. So again, we get a graph at the top that we can break out, and you hover over the graph, and it'll give you a little information about each of the hosts in this instance. And again, you've got the table at the bottom. So again, we can drill down even further and say, right, this host is using a lot of HTTP. Let's see what else, what other applications this host is using. And again, we drill down even further, and we can see that it's primarily all HTTP. So that's the individual. So that's looking, starting from a very high level and looking into web traffic, and we can then drill down to, right, it's web traffic. It's this proportion of HTTP traffic going into HTTP, right? It's this host that's using all of our bandwidth. So you can then have full visibility of your groups of traffic, your individual applications, and your hosts. Just moving back to the first screen on the applications we saw, we started off with the groups of applications. We can also then just break it down and see all of the individual applications, not just the HTTP. So again, we can then see that HTTP is taking up the most, and again, MySQL. And again, we can drill down from here to be more specific to find out which hosts are actually using that traffic. Not only is the applications that we can see, but because we can monitor at layer 7, we can actually see which URLs people are going to inbound and outbound. So we see there's an internal one there, there's Liquor King, so somebody's obviously planning a party or something like that. So we can see the actual links that people are going to, and again we can drill down. So all the information you can see, you can get a very high level view of it, and then we can then drill down and see which devices are actually going to these websites. Not only do we have just like web traffic, but we can also then monitor voice, and we can get some statistical information from the voice data that if that's going over your network. So we can get a little bit of information about the calls that we're seeing, the jitter, the delay, the MOS score on all the calls. So if somebody rings up and complains, yesterday the voice was really bad, it was very patchy, we can go in and we can then actually analyze that data and see which calls were causing the issues. When you see a graph like this, it might give a very broad spectrum of what you're seeing. By dragging your cursor over the graph, you can then actually zoom in to that proportion to see a little bit more data and get a closer view of the graph. And you can keep on zooming in at any point you wish, and then you can then come back out to the high-level view. So that's the applications. In that list, you will see lots of IP addresses. Sometimes that, for some small organizations, that's why you know which IP addresses of which servers and of which users. However, for large organizations, that can be a little bit meaningless. So with Exindra, they include a little application that you install on a domain controller. And what that does is that monitors log-on events with the IP address. So it associates a username with an IP address. So all of a sudden, you get a little bit more meaningful information. So we can see that Lucas has been the top user for this company, using up to 300 megabytes of information. And again, we can then drill down further and have a look at Lucas and see what applications he's then using. And we see most of it is HTTP, but in fact this user is actually using a fair amount of BitTorrent. So that then gives you information, and Facebook as well. So we can see that he's actually using BitTorrent, and outbound, BitTorrent accounts for the majority of the traffic that he is using. So we know that he's probably doing quite a bit of uploading there. So we may want to then start to target that and investigate that. Exindra also has the network objects. So you can break it down, so you can break a network object down to different sites, different buildings, different departments. And these are what we call the subnets. So we can then see what type of subnets we are seeing. So our external subnets, we see are all our external offices. So we can see here we've got some branch offices, we've got an office in Los Angeles, and you can then break down the data that we're seeing going to and from those offices as well. So we can see where the data is flowing through if you've got multiple sites. And again, you can view the applications or the hosts or the conversations for each of these, and you can drill down at any point as well. We can also then just see a very high-level overview to see what applications we are seeing on the net. So we can see, so here this graph is showing the inbound applications. It breaks it down into the different colors for the different applications. And again, we've got a huge spike there. So let's zoom in on that, and then we can see which applications have spiked. So we can see that actually HTTP has spiked there at some point, which you can then drill down, and you can, then start to investigate. You can also see an overview of your link utilization as well to see how much bandwidth you're using. It gives you a peak and also an average. So that's all the visibility that you get to see with an Exindra box. So once you've been running this and you've looked at what traffic you've got, now you want to control that traffic. You've seen that BitTorrent is running away on your network, and you want to, rein that in and give back bandwidth to other business critical applications such as mail, web, etc. So we then go into the optimize, and this is where we build all our rules for our control. And this is where we can put the control in, and we can also put the optimization and actually accelerate just individual applications if we so wish. Rather than accelerating all the web, we can break that out into different applications and only accelerate internal web traffic between two sites for internal stuff, for example. So here's the optimization. It works in a firewall-based top-down approach that traffic will come in and it will go through all the rules. When it hits one, it applies the rules that are in place there, and away we go. So there are three key components to what we're looking at for each rule. First of all, we have the first figure, which is the minimum guaranteed bandwidth that that application will receive. All of the minimum bandwidth cannot add up to more than 100%, obviously. However, the second one is how much bandwidth that application can burst to. So if it is needed and it needs to take up 100%, it can go up to 100%. In terms of things like BitTorrent and peer-to-peer sharing, you want to choke that. You want to throttle that down. So here we can give it a minimum of 1% and a maximum of 3%. So we're not banning the applications, because if you block the ports, some of these peer-to-peer applications actually are intelligent enough to then start trying to go around and find ways around, use different ports until it can find one that it can actually get a successful connection to. By throttling it down to 1%, the software realizes it's got a connection, so it's happy. However, you're only going to be downloading a very small amount at a very slow rate, and so any users that are going to be actually trying to use any peer-to-peer stuff will then be won't get very far. The third option is the priority. So we can see at the bottom here we've got files, web, and mail, and we can see here that they all can burst to 100%. So what happens when two applications want to use all the bandwidth at the same time? It goes off the priority. So we can see that voice is quite critical. You don't want all of a sudden bandwidth to be used by another application when you're on a call like we are today, and it then starts to break up. So that has been given a priority of 1. Whereas web traffic has been given a priority of 4, and mail a priority of 6. So if they burst together, they will go in that priority. So let's just take a quick look at one of the policies themselves. So each of the policies can be applied on a schedule. So for web traffic, you could have it in work hours or after hours. So you could say, right, restrict it during work hours, but after hours, everybody's free to go. What you want to do you want to optimize it? Which direction? Do you want it just for specific hosts or network objects? In which direction? What application? So not only can you select the groups of applications, you can actually create one for individual applications as well. So if you wanted just to optimize Citrix traffic, you can do without optimizing all of the other thin client traffic, which Citrix is a member of, which includes RDP and PC Anywhere, etc. So you can just prioritize individual applications themselves. You give it a minimum bandwidth, maximum bandwidth per burst priority, and then do you want to do any acceleration on there? Obviously with edge caching, which is it caches websites, it caches video. So if somebody sends a YouTube link around the office, they'll watch it, it will download from YouTube, they'll watch it, they then send that link around the rest of their mates in the office. When they go to view that application, that video on YouTube, it won't be downloaded from the internet, it will be viewed off the cache. So caching is so viewing it and caching of the video is very quick, and it's then also saving your bandwidth, because you then haven't got 20 people all going off to YouTube to watch a dog do a funny trick. So that's how you build individual policies. So not only do you have control there, you can then put the optimization techniques into place as well for the individual application. So just for web, or just for an individual layer 7 signature. So you could put places in for Twitter, for Facebook, etc. With the idea of network objects, we have these virtual circuits. So we can then break these policies down to different network objects. So the first one is from the WAN going to the branch office. So any traffic going to the branch office from the WAN will have all of these rules applied. The bottom one is going out to the internet from all. So we can then apply different policies to different traffic going to different locations. So you can prioritize web traffic going to one place. You can apply different prioritization to Twitter coming from the marketing department, but then have a different policy for people in the HR department or the sales department. So you've got great control there. One final thing just before I want to end is I just want to show you the applications and how they are listed. So first of all, you've got all the list of applications, and these are just straight out of the box. So Exinder's got some predefined applications. Not only is it just protocol and the port number, but we can also then see things like the Adobe updates if it's coming from, which is a layer 7 signature, HTTP going to the host of Adobe. So we can prioritize or restrict just the Adobe updates if we wanted to. All of these are completely editable. You've also got application groups as well. So these are the built-in Exinder groups that we are seeing. These groups are, again, completely editable. You can delete an application out of the group if you want and put it into its own group. So I think that's about all I want to show you today. I'll pass back to David for any questions.
Wonderful. Thank you very much, Justin. And thanks also to David Richards. If we may, we just prompt any questions now. We actually have had a couple of questions actually come in during the presentation. Just a reminder though, if you have any questions, please post them in the question box. Okay, so just looking at these questions, I guess this first question probably best to David. How is the Exinder solution sized and licensed?
Sorry, how is the Exinder solution sized and
licensed?
Oh, licensed. Okay.
Yeah.
Right. Well, there are a number of products within the range, so we can basically scale from approximately 256K up to 5 gigs. So there's a broad range of technology, and the products do overlap in their licensing models. So it gives us the capability, for example, of providing more horsepower on a smaller link if there's a broader range of applications. So the way the product is licensed is we would work with the customer to identify where the product is going to go and on which links. So, for example, if we were just looking at a visibility and control perspective, and a perfect example is a project I've worked on recently with a city council where they have 200 meg links centrally and they're sharing applications with their libraries. And it turned out that the libraries were actually consuming approximately 60% of the overall bandwidth, which was performance impacting to the city council. So what we were able to do was set up separate subnets for each of those groups and then apply controls and shaping to the library's traffic, even down to individual users and time of day. So in that instance, we were looking at a single appliance with 2 bridge cards, each capable of supporting shaping, if you like, or control up to 100 meg. Does that answer the question?
I certainly hope so. I think it does for me. Of course, if anyone wants to contact us afterwards about questions.
No.
Sorry.
So, we could deploy a small product, one of the smaller products, which would be a 2000 series with a visibility control license on a 2 meg circuit. So that would be a 2761-2, and that's licensable up to 10 meg. And then the next product up is the 4000 series, and that again starts off from memory at 6 meg. So you can see the overlap between the products.
Brilliant. Okay. Next question. We've had quite a few come in here now. So where would this unit sit physically in the network?
Right. Do you want me to take that, or?
I think Justin, maybe you want to answer that one.
Yeah. Typically, what it'll sit on the clean side of your network, just inside your firewall, between your firewall and your core switch. It's typically where it will sit, and that way we've got complete visibility of the applications going out. If you're then using VPN or anything like that, we can see that data because it's on the clean side of the firewall.
Brilliant. Okay, thank you for that. Okay, so there we go. I've got another question here. It's way beyond my technical ability. It says the demo showed a relatively small number of conversations being monitored. How many conversations can Exzinder cope with? For example, my edge firewall is currently showing over 100,000 sessions.
I think I'll answer that. I'll try and let me just find in terms of the connections, they can go up to the millions in terms of concurrent connections. I'm just trying to find the list of for each of the boxes, but the smaller boxes obviously can only hold a few, and the top level can obviously hold a few, a lot more. I'm just trying to get some statistical data for you here. So a 4000 box, so one of the lower end devices, can actually then cope with the top end box, which can go up to a license bandwidth of 250 meg, can cope up with a little over three quarters of a million, so 768,000 concurrent flows going through it. So that's one of the smaller boxes that it can cope with.
Okay.
That just gives you an idea. Obviously, that's one of the small boxes, and the bigger boxes can do a lot more. Okay,
wonderful. That seems to answer that. There's one final question, and that is to do with creating. How would you actually create an application object that is bespoke? So an organisation would create a bespoke application. How would you actually create that within Exzinder to monitor that and control it?
I'll take that one again. I don't know if I can show you that. It's very easy. I don't know if you want to just throw the control back to myself there, David. During those final few screens that we saw, which listed all the applications, there was a section at the top which meant that you could create your application. So here we go. Hopefully you should be able to see my screen now. So this section at the top, we can give the application a name, whether it applies to a network object. Are we going to use a layer 7 signature for it? So HTTP, for example, host. We can then put in there anything, Twitter if we wanted. We can either use a layer 7 signature there, or we can just use a protocol TCP. And if you have a bespoke application that uses TCP on port 2545 or some random number, you can create an application there for that bespoke application. Sorry, a definition for the application. You can also create your own groups as well and put those bespoke applications into their own individual groups. So then you can prioritize all of those applications just in one hit via the group.
Brilliant. Well, thank you very much for that, Justin. Justin, if you could just pass back to David Richards. Perhaps, David, you could just put the last slide with the contact details up. At this point, I'd like to obviously thank everyone for joining us today. There's been a fair few of you on this session, so obviously it's a topic that's very relevant at the moment. If you have any questions, please don't hesitate to make contact with us. The telephone number's down there on the bottom of the slide for network utilities. That's 020-8783-3800. Excuse my phone ringing there. And also, if any of you would actually like to have a trial, to have actually a play with the Exzinder solution, you can actually go onto a live demo server, and that's at the URL that you can see there, which is http://www.exzinder.com/demo. So I don't think we've actually got any more questions. So once again, thank you for your time. Thank you, David, and thank you, Justin. And we look forward to speaking to you in the future.
Well, thanks very much.
Bye-bye.